Okay, MCT4C, lesson 1.2. This is day 3. Yesterday, we determined exact values of trig ratios for special angles, and here's 2 very typical examples. And we actually yesterday learned quite a few concepts, and we'll see most of those in the 3-minute review today. So, stating the sine of 135 degrees exactly, I think we're going to draw a diagram. Let's draw a diagram, okay? 135 degrees, where's that? Well, we know we start the rotation angle from the positive x-axis. That's 90. 180 is too much, so it's halfway in between. And the key here is actually figuring out what the related acute, the reference angle is, what this is in here. And it's 45, isn't it? Let me write that in there. That's 45 degrees right there. So this is 135 degrees. There's actually 2 ways we can state the sine of 135, and one way is to construct our special triangles, right? The special 45 triangle is the 1, 1 square root of 2, isn't it? Well, the thing is here, since we're moving left, the x-coordinate's negative. Up, the y-coordinate's positive, and then we can write the sine of 135 as just opposite over hypotenuse. One over the square root of 2. Now, what's strange about this? Hopefully, you're recognizing this as one of the special angles that we got in our chart. And as part of the 3-minute review, I'm going to go through how to come up with that chart real quick. If you're good with building the triangles like this, then you keep doing that, okay? But I'm going to go through the chart real quick here. Sine, cos, and tan. And then we got 0, 30, 45, 60, and 90. Sine starts at 0, ends at 1, then halfway between a half and 1 is 3/4. And then remember the square root of everything. Right? Square root of everything. Square root of 1, square root of 4 is 2. Square root, square root, square root, square root. And the start and end the same, that's fine. Remember, cosine is just this other one backwards. And tangent was just sine divided by cos. Square root of 3 over 1. And then this one's undefined. Or error, however you want to write that. We never use this chart much, but what I want to point out here is that our reference angle 45 was this line in the chart. Notice the sine of 135 ended up being this spot right there. What's strange is sometimes it'll end up being positive or negative. This one, it's positive, but notice if we had the cosine of 135 degrees, we would have read it over here, adjacent over hypotenuse negative 1 over square root of 2. And if we would have read it from the chart, same reference angle, but we would have missed the negative sign. And so, sometimes it feels like we could get the chart except for this idea of the minus sign. We'll see that more today. Another thing that we talked about were these special angles, cos of 180 degrees. And we can't just fire this into a calculator. We have to think about this a little bit. And the way we thought about this is by putting it on a unit circle, right? Let me draw a unit circle. I could use some work on my circles, but that's okay. 180 degrees is right there. And if this is the unit circle, right, this is 1, then this point, remember the xy coordinates are the cosine and the sine. This point right here is left 1, and the y coordinate is 0. So then that is the cosine of 180 degrees. Cos 180 equals -1. All right, that's the 3-minute review. On with the lesson. A bit of a long lesson today, so let's get right at it. Lesson 1.2, trig ratios from 0 to 360. We did this yesterday, except for it was with special angles. So this is with any angle now, not just special angles. Example 1 we're going to talk about is we're going to discuss this idea of where each of the trig ratios is positive. So we're supposed to say x, y is on the terminal arm of a rotation angle theta. Which of the primary trig ratios are positive in the first quadrant? So if x, y is in the first quadrant, I'm going to draw one of these and just use it over and over again. Let me see if I can draw a decent circle here. There we go. Oops. Copy that. Oops. Edit, and I'm going to paste that so I can use it again later. Maybe not. Put that together so we'll have a couple. All right. Good. Dandy. So in this first quadrant, which of the trig ratios are positive? Well, we said if that's x, y, right, there's our little triangle, there's theta. X is the cosine, y is the sine. So in the first quadrant, right and up, well, cos is positive and y is positive. Also, tan, because it's opposite over adjacent, y divided by x, everything's positive in here. So not only is, the cosine and the sine, all of them. So I'm just going to write all for A. Now for B here, second quadrant. Here's our point x, y. We see that the x coordinate's negative, right? So the cosine's going to be negative. It's not all of them if the cosine's going to be negative. The y coordinate, which is the sine, remember, is positive. So the sine's positive. There. Sine's positive in this quadrant. What about the tangent? Well, the tangent is opposite over adjacent. Positive divided by negative. Nope, the tangent is negative. So just the sine. And now I'm going to paste another one of these in here and struggling. There, group that. Now there we go. Now we're talking. Let me put the fourth one there too. Here we go. So down here, the third quadrant, which ones are positive? So if this is x and y, x coordinate's negative, isn't it? Y coordinate's negative. So cosine is negative, sine is negative. Is the tangent negative as well? Maybe none of them are positive. No. Tangent is opposite over adjacent. A negative divided by a negative. There you go. The tangent is positive here. Tangent is positive in the third quadrant. Now what about in the fourth quadrant? There's theta. There's the point xy. I can see the adjacent side. The x coordinate is positive. The y coordinate is negative there, right? Because we're going down. X coordinate's positive, so the cosine's positive. Right, the cosine. Cosine's positive, right? Y is negative, so the sine is negative. And tangent, opposite over adjacent. negative divided by positive negative. So the tangent is negative as well. So only the cosine is positive in the fourth quadrant. Now we've put all this together. Make a long story even longer. Which ones are positive? This is kind of like a summary one. Well, in the first quadrant, all of them are. So I'm just going to put an A for all. In the second quadrant, it was just the sine. So I'm going to write an S for sine. In the third quadrant, it was tangent's positive. And in the fourth quadrant, the cosine's positive. And this is what's called the cast rule. And the cast rule essentially just tells us which trig ratios are positive in each of the quadrants. How that's useful, we'll see that soon. But notice the cast rule is kind of weird in itself because, we start counting in the first quadrant where all of them are. So, a better thing would be ASTC. Sorry. ASTC, but that's pretty hard to say. Cast is easy to say, but another way to remember it is all soup turns cold. ASTC, all soup turns cold, and then that way you can start counting in the first quadrant. Okay, I'm going to stop this video here, and we'll get on with the examples in a second.